Hey guys, welcome to the next physics lesson, and today we will be talking about the topic of velocity. So, remember back in like maybe the first episode, we talked about what a scalar and a vector was, and we talked a bit about speed and velocity. So let's do a quick recap here. So we said that speed was what? We said that speed was a scalar, and the difference between the speed and velocity was that speed was a scalar and that velocity was a vector. And if you guys don't remember, a vector is, just recap, a vector has what? It has a magnitude, for magnitude, and a direction. Whereas scalar has a magnitude, but no direction, right? So for example, when you're driving in a car and your speedometer, that little thing on your dashboard that says what speed you're traveling at, that tells you your speed because it doesn't tell you which direction you're heading. Like you could be traveling north, south, east, west, and it doesn't tell you which direction you are traveling in. So the symbol for speed is a v, and the equation for speed is distance over time. So you can so basically in your an example of a speed that you will see in your car would be, let's say, 50 kilometers per hour. And we use kilometers per hour and not like miles per hour because kilometers is the SI unit. Well, meters is, but kilometers is just meters times 1,000. So we use kilometers, not miles. Just keep that in mind because if you use miles, your whole equation will be wrong. So we use kilometers and hours. And no, there is no direction in here because speed is a scalar. So speed equals, let me just write it out in words. Speed, which is v, equals distance, which is just d, over time, which is t. And that is speed. But what about velocity? And let me just scroll up here. So velocity has a magnitude and a direction. So velocity, since it is the counterpart to speed, it should have essentially the same formula. But the only difference is that velocity is a vector, so we use a vector hat. And instead of d, because d is distance and distance is a scalar, we have displacement, which is what we learned last lesson. And displacement is a vector, so that's why we are using displacement and not distance. And over time, and I'm going to use change in time because this is more formal. This is actually what it means. Because time, when you're saying just t, you're assuming that the initial time was 0. But change in time, you could start at 2 seconds to 5 seconds. So change in time is a better way of stating the equation. So let me just write out in terms here. So velocity, velocity is represented by a v with a thing on top, the vector hat. Velocity equals displacement, which is the change in position, as what we just said, what I explained last lesson, over the change in time. An example of a velocity would be, using the same example as before, 50 kilometers per hour north. And so far, I don't think any car has the direction put in place yet, because that'd be too advanced. Anyway, so, and just to keep in mind, when we use distance over time, I mean, when we are using this equation, we are actually using it. Displacement should actually be in meters, and time should be in seconds. These two units are the SI units, and SI units are basically the units that you have to work in with. The units that you have to work with when doing any equation. So let me just write that down. SI units. And SI units, like if you use, I mean, for now it doesn't really matter, but SI units are like the rules that the scientific community put in place just to have some consistency. So for example, it would be meters, seconds, what else? Kilograms. These are all SI units, but it's not really that important right now. If it's important, I'll tell you guys in a future episode. So this is basically actually, let me just draw a box around the essential formulas or formulae. I'm going to write down here actually. So just recap: speed equals d over t, and velocity equals change in d over change in t. So these are the essential formulae that you need to memorize. So speed equals distance over time, whereas velocity is displacement over time. Okay, now the next equation that you have to learn is called the average speed. So what is average speed? What is the average? Oops, I didn't mean to draw that. What is the average speed? Well, average speed is basically this. Oh, whoops. Total distance over total time. So the total distance you traveled over the total time you traveled. And the same thing for velocity. I'm going to do it in another color actually, just to show that there's a difference. Hold on. Okay. So velocity, average velocity equals change displacement again, but instead of just displacement, it's total displacement over total time. And yeah, so the difference between average velocity and average speed and average velocity is that it's just the top part, distance and displacement. So let's say Bob was in a car and his car traveled in a loop like that. So started from here and he went around in a circle around a city and came back to this same spot that he was in. His average speed would be the total distance he traveled. So let's say it's about 2.4 kilometers. So let's say Bob traveled 2.4 kilometers around the city block and came back to his house. And his time he took was an hour. So his average speed would be the total distance he traveled, which is 2.4 kilometers, over the total time he traveled, which is 1 hour. So it would be 2.4 kilometers per hour, and that is his average speed. And I actually have done it in yellow because yellow. Anyway, so that is average speed. However, what is his average velocity? And this is the tricky part here, because remember what I said about displacement in the previous episode. The displacement only cares about the starting and the finish point. It doesn't care about which path it took. So what are its starting and finish points? Well, let's write it down. I'm going to use it right now. Average velocity equals change in dt over total displacement over total time, which equals to initial final position minus initial position over the change in time, which equals to, what is his final position if we call it 0? It would be 0 minus what? 0 again, because he came back to the same spot he was at, over the change in time, which is just 1 because 1 hour. So his average speed would actually be only 0 kilometers per hour. So you can see the difference between each of these. His average speed was 2.4 kilometers per hour, whereas his average velocity was 0 kilometers per hour. And this is the difference between these two. And this is probably why we don't use velocity in our speedometers. That's why we don't have velocimeters, because if you came into the same spot, your average velocity would still be only 0. So I guess that wouldn't really help us. So yeah, these are the main differences between speed and velocity. Speed is a scalar, which equals distance over time, and since distance cares about the path, velocity is the total distance, which is the total distance he traveled, 2.4 kilometers over time, whereas average velocity deals with displacement, and displacement only deals with the final position and the initial position, which is in this case 0 and 0. And we calculated and we got 0 kilometers per hour. So yeah, that's basically speed, velocity, and their averages in a nutshell. Hope you guys learned from this video, and if you have any questions, feel free to leave it in the comments below or inbox me. And until next time, guys, where in the next episode I will teach you guys about the final one, the acceleration. Peace out.